Hi, today we're going to learn about linear equation to variables. So in this section, I will go over the different types of linear graphs and all of their properties. I will go over the slope-intercept form, point-slope form, standard form, vertical line, and horizontal line form. Also, I will go over a word problem involving salary. So here's a little introduction about linear equations. You've probably seen this before. So this might be a review. So a linear equation in two variables has a graph has an equation of y equals mx plus b, and where m equals the slope and b is the y-intercept. So here are some examples of what a linear equation might look like. It could look horizontal, exactly like this, so the graph would be y equals 2. It could also, let's see, the most popular one is either these kind of graphs. So it either could be positive. Linear graph could go in the positive direction. It can have horizontal shifts or downward shifts, vertical shifts as well. And then another form of linear equation can also be completely vertical, so like this. Oops. So it's completely vertical. We'll call this graph x equals 2. Okay, so here's some examples of linear equations. So what's not an example of a linear equation? So basically what's not an example of linear equations are, let's see, a parabola, right? That's not a linear equation. The x cubed graph, and the negative x cubed graphs, that's not linear. The absolute value is not linear, and neither is a circle. So now, okay, now let's go over some properties of linear functions. I mean, linear functions and linear equation are the same thing. So here are some properties. Here are some properties of linear equation in two variables. So as you can see, the domain is all real numbers and the range is all real numbers, because here I will show you. To figure out the domain, you look at the y value on the positive side. So as y value increases, what happens to the x values on the positive side? It increases. Now let's look at the negative. As y decreases, the x value also decreases. So that's why the domain is all real numbers and the range is all real numbers as well. It's a function since it passes the vertical line test. So remember the vertical line test, it cannot have the same x value, so it passes the vertical line test. So if it hits it more than once, then it's not a function. It's also a one-to-one. It's also a one-to-one function since it passes the horizontal line test. It does not have the same y value, so I think the one that doesn't work is when it's completely vertical. That's when it's not a one-to-one function. But this one definitely has a one-to-one function, because if you put a line through it, it only hits it once, so it has an inverse, so it's a one-to-one function. What else do we know? So yeah, so that's what it's a one-to-one function, so it must has an inverse. So those are some properties. Now let me go over some formulas of linear equations. So some of the formulas. So you probably remember this. So we know that slope is y2 over y1 over x2 over x1. We also know that slope can also be the rise over run. And then linear functions can be in 5 forms. It can be, the first one be the slope-intercept form, which is the most common one, y equals mx plus b. We also have point-slope form, where you have y minus y1 equals m times x minus x1, and then we also have the standard form, ax plus by equals c, and then we also have vertical line where x equals a, and then the horizontal line y equals b, right? So now let's talk about parallel and perpendicular lines of linear equations. So remember parallel looks like this. These are two parallel lines. So what does it mean when two linear functions are parallel? It means that their slope, this graph and this graph, must be the same. So an example would be y equals negative 5x plus 2. Let's say you wanted another linear equation that's parallel to this one. So the slope will also be negative 5 as well. So that's how you know two lines are parallel. Their slope must be the same. What about perpendicular lines? How do you know if two lines are perpendicular? So you basically take the slope of the first line times the slope of the second line, and then that should give you should equal to -1. So m2 is pretty much the negative reciprocal of m1. So an example would be, let's say you are given linear graph of y equals 2x plus 7, and then they want you to graph another linear equation that is perpendicular to this one. So the first slope, or m1, is 2. So what would be m2? So m2 should be the negative reciprocal. So m1 is 2 over 1, so the reciprocal of that would be 1 over 2, and then you just add a -1. And to check it, you just simply put times 2 times -1/2, and that should give you -1. So those are parallel and perpendicular lines. Now let's try to let's go graphing linear functions. There's actually two ways you can graph a linear equation. I keep saying equation and function, they're the same thing. So let's talk about graphing these. So graphing a linear equation, there's actually two ways. We can start with the most common, most popular way. Let's say you're given y equals 2x minus 1. So when we know that our slope is 2, because y equals 2x is in what form? Is in this form, which is also called the slope-intercept form, right? So we know that m is 2, which is the rise over run, and we know our y-intercept is -1, or in coordinate form it would be 0, -1. Okay, so the first way is you just start with you graph the y-intercept, which is at 0, -1, and then you do the rise over run. So we know our slope is positive, so we're going to go head up to this direction. So we rise up 2 and run 1. So from the y-intercept at -1, go 1, 2, 1. 1, 2, 1, 1, 2, 1, etc., etc. You can also go, since we know it's going this way, you start at the y-intercept, and then you could go down 2, 1, 2, left 1, down 2, left 1. And then you just connect the dots. And then you always label the graph y equals 2x minus 1. The second way is probably, so the second way is to graph a linear function, you pretty much need 2 points. So you can find the x-intercept and the y-intercept, right? So to find the x-intercept, you simply plug 0 into y and solve for x. So remember our original equation was y equals 2x minus 1, right? Y equals 2x minus 1. So to find the x-intercept, you plug in 0 for y, so it's going to be 0 equals 2x minus 1, and then you solve for x, so I'm going to add 1 to both sides, and then I get x equals 1/2. But you always want it to put your intercepts in coordinate form because it's going to be easier when you graph it. So the x-intercept in coordinate form will be 1/2, 0. The y is always 0 for the x-intercept. Now, you need another point, and that other point will be the y-intercept. So to find the y-intercept, you simply plug in 0 into x and solve for y. So remember, you're given y equals 2x minus 1. So wherever you see an x, you plug in 0. So it's going to be y equals 2 times 0 minus 1, which you get -1. So the y-intercept is 0 in coordinate form, 0 minus -1. Now you can just graph it because you have 2 points. So here is our x-intercept at 1/2, 0. So notice how it hits the x-axis. And then our other point is at 0, -1. It's right here. So this is 0, -1. And then this is 1/2, 0. And you notice the y-intercept hits the y-axis. So you only need 2 points to graph it, so you connect the dot and then label it. So for that way, I usually don't do it that. Usually do the second way because it's much longer and it just takes more work. But we will be using that way when we have to deal with inequalities, or if your slope is in decimal or fraction form, or if the equation is in standard form, which has decimal variables. And I'll show you what I mean when we actually do the problems. So let's start actually doing problems. So no, let's start with, let's do it. It says find the slope and y-intercept of the equation of the line. Sketch the line. Okay, so what I'm going to do is I'm going to graph it in 2 ways because I really want you to understand how to graph a linear equation, and you have 2 ways to graph it. So one way is I'm going to put it in, so what form is this? 2x plus 3y equals 9. This is what's called the standard form. Right? Standard form is like ax plus by equals c. But in order to graph the first way, you got to put it in slope-intercept form. So first step, I'm going to put it in slope-intercept form. So to do that, you just simply solve for y by itself. So this is what you're given, 2x plus 3y equals 9. And then what I would do is subtract 2x from both sides. So you're left with 3y equals -2x plus 9. And then I'm going to divide everything by 3. So you're going to get y equals -2/3 x. And then this 3 means you have to divide everything from both sides. So this side and this side as well. So 9 divided by 3 is 3. Positive 3. Now we can graph this slope-intercept form, right? So we know that our m is -2/3, and we also know our y-intercept, or b, is 3, but in coordinate form it's going to be 0, 3. So let's graph it. This is our x-axis, this is my y-axis. So let's start with the y-intercept at 0, 3. So 0, 3 is right here. Now our slope is it's negative, right? So it's going to go this way. So I can either do 2 options. I could go up to 1, 2, So 1, 2, and then 3 to the right or left? Left, because we were going negative. So it's 1, 2, 3. Oh, sorry. So from the y-intercept, 0, 3, go up to 1, 2, and then go left 3. 1, 2, 3. And then if you don't want to do it that way, what you can do is start at the y-intercept and go down to right 3. So here's 3. So go down 2, 1, 2, 3 to the right. 1, 2, 3. And then you just connect your dots. I'm so sorry if my line doesn't look straight or even. And then always label the graph. Y equals negative 2/3 x plus 3. That was one way. Now let's do it the other way. So how do I do it the other way? Okay, so let's say, you're given, remember it's standard form 2x plus 3y. Let's find our x-intercept and our y-intercept. So find x and y-intercept. So to simply find the x-intercept, you plug in what for 0? Y. So wherever you see in y, you plug in 0. So it's 2x plus 3 times 0 equals 9. So that's just 0. So it's 2x equals 9. Divide by 2, divide by 2. So x equals 9/2, which is about 4.5. About 4.5. So our x-intercept in coordinate form would be 4.5, 0. Now let's find the y-intercept. So our y-intercept is you plug in 0 for x, right? So it's 2 times 0 plus 3y equals 9. This becomes 0, so you're left with 3y equals 9 divided by 3, y equals 3. So our y-intercept in coordinate form is going to be 0, 3. And then you could just graph those 2 points, because that's all you really need. So 4.5 is 1, 2, 3, 4, 5. So here's 1, 2, 3, 4, 4.5. It's right here. And then our y-intercept is at 0, 3. So here's 1, 2, 3. There you go. And then you just connect the dots. I should touch. And then label the graph. We can label this 2x plus 3y equals 9. So that's 2 ways to graph it. So let's do another problem. What section am I in? 6. So let's do another one. Okay, so it says write an equation in slope-intercept form for each of the lines. So we need an equation for this linear equation, but they only give you 2 points, and they want it in slope-intercept form. So slope-intercept form, remember, is y equals mx plus b. Oops. So how do we do this? How do we find the equation for this? So first off, we need to find the slope, right? Remember, slope is y2 minus y1 x2 over x1. And they give us 2 points, so we can use the slope. So they give us this point, 0, -1, and then 3, 1. So what I'm going to do is label this x1, y1, x2, y2, and then just put it in this formula. So what is our y2? x1 minus, what is my y1? A minus -1, so it's 2 negatives. What is my x2? 3 minus, what is my x1? 0. So this becomes 2 negatives, becomes a positive, so the numerator is 2 over 3. So that's how so we know our slope. Okay, m is 2/3. Now we don't know our b or y-intercept, so how do we do that? You just simply use this formula, y equals mx plus b, and then you pick a point. It doesn't matter which one. It could be this one, this one. I'm just going to use this one because there's a 0. So we know this is our 0 is our x, and then -1 is our y. So put it in this equation. So our y is -1 equals, and we know our slope, which is 2/3 m, times it by x. So what is our x? 0 plus b. This becomes 0 plus b, -1, and so we know our b is just -1. So now we could put it in, we now know everything, and we could put it in this form. So y equals m, which is 2/3, times it by x, plus b, which is -1. So it's going to be -1. So that's how you write it in slope-intercept form when you're given 2 points. So that was 7. Let's do 8. So this problem asks us to find the equation of line through the given pair of points in standard form using integers. So it's kind of like the last one, but the only difference is we have to put it in standard form. So remember, standard form is ax plus by equals c. So, but before I do that, before I put it in standard form, I'm going to have to put it in point slope form, right? So first I got to put it in this form, point slope form. Then I could put it in standard form. Okay, so first I got to find m, right? I don't know my slope, so I'm going to label this x1, y1, x2, y2. So my slope is going to be y2, which is -1, minus y1, which is 3, all over x2, which is -3, minus x1, which is 2. So -1 minus 3 is -4. -3 minus 2 is -5. We all know that 2 negatives, when you divide, it becomes a positive, so it's just 4/5. So now we know our slope. Now we got to find our y1 and x1, so you simply got to pick a point. Doesn't matter. I'm going to just use this point. I'm going to circle it because I don't want to get confused. So put it in this, point it in the point slope form. So it's going to be y minus y1, which is what? 3, right? y1 is 3, equals m, which is our slope, which is 4/5, times it by x minus, what is my x1? It's just the x, so it's just 2. So I'm going to FOIL it out now. So this is going to be 4/5 x minus 8/5. And then you have this y minus 3. Bring down this y minus 3. Before I do anything, okay. So we want it in standard form. So basically we're putting all the variables on one side and all the whole numbers on the right. But before I do that, I have a fraction, right? I don't like fractions, so if I want to get rid of it, so how do I do that? I simply multiply by the common denominator. So we have a 1 here, and a 5, so our common denominator is 5. So this bracket means we're multiplying everything by 5. So this is going to give me a 5y. This is going to be a -15, right? 5 times -3 is 15. And then over here, the 5 cancels, so you're just left with 4x. And then over here, the 5 cancels, so you're left with -8. Now I want it in this form, so I got to put all the variables on one side and all the numbers on the other side. So what I can do is I can move this 15 to the right, so I'm going to add 15 to both sides. So we're left with 5y equals 4x. And then what is negative 8 plus 15 plus 7? We're almost there. Now I got to move this 4x to the left because I want all the variables on one side, so I'm going to subtract 4x. So my final equation in standard form, I'll put it right here, is negative 4x plus 5y equals 7. So that's how you write an equation in standard form when you're only given 2 points. So that was section 8. Let's do section 9. Now this problem asks us to find the slope of a line described. A line, we got to find the slope of a line that is parallel to y equals 0.5x minus 10. So what do we know about parallel lines? The slope of m1 must equal to m2. So what is our m1? What is our first slope? m1 is 0.5, right? So the questions ask, find the slope of the line described parallel. So what would be my m2? According to this rule, they must be the same, so m2 must be 0.5. So let's do section 10. So now, this one's kind of longer. We got to write this, so the question says, write the slope in intercept form of the equation of the line L through the given point A parallel to the given line, and B, we got to find perpendicular to the given line. So what they're asking is, so it says write the slope intercept form. Okay, so we're going to have two lines, one that is parallel and one that is perpendicular, and they all got to be in slope intercept form. So let's do the parallel. So in slope intercept form, we have to make it as y equals mx plus b, right? What form is this? This is standard form. So to get it in that form, slope intercept form, you simply solve for y. Get y by itself. So I'm going to subtract 4x. Get negative 2y equals negative 4x plus 3. And then I'm going to divide everything by negative 2. So I get y equals, let's see, 2 negatives becomes a positive, so that's a 2x. And then 3 divided by negative 2, because we have to divide everything, is negative 3/2. Okay, so now we gotta first find our parallel line. So we know that parallel lines their slope must be the same. So let's see, we are given a point, so here's our equation, y equals 2x minus 3. Okay, so over here, so m1 is this slope, right? 2. So what must be m2? If they're parallel, they must be the same. So m2. So remember y equals mx plus b. So our slope is going to be 2x plus b. We don't know the b. How do we find the b? You simply plug in the point and then solve for b by itself. So this will be our point. So that 1 is going to be our y, and 2 is going to be our x. So we said that our y is 1 equals 2 times x, which is 2, because that's our x, plus b. 2 times 2 is 4, plus 1, plus b. And then we said we did solve for b, so we're going to subtract 4 from both sides. So I get 1 minus 4 is negative 3 equals b. Now we can find our linear equation in slope-intercept form. Will be y equals 2x minus 3. So this is part A, because this is when they're this is the line that is parallel to this line, y equals 2x minus 3 halves. So if you were to graph this and put this in a calculator, you will see that these both lines are parallel. Now let's do part B. We want something that's perpendicular. So we're going to do perpendicular lines. So what do we know about perpendicular? We know that m1 times m2 should give you negative 1. So m2 is pretty much the reciprocal of negative 1. So remember, let's go back to this graph. Whoops. Y equals 2x minus 3 halves. Remember, so we know our m is 2. So what would be the slope that's perpendicular to this one? So m2 must be the reciprocal of this one. So what is the reciprocal of 2? 1/2, right? You just flip the denominator and numerator, so it's going to be 1/2. So did you see what I did? I just literally flipped this and then get 1/2 and then add a negative. So m2 is negative 1/2. So now we got to put it in this form, y equals mx plus b form. Now how do we do that? Remember, we're given a point of, what is it? 2, 1, right? So this is going to be our x and this is going to be our y. So our y is 1. Our m, which is pretty much m2, which is negative 1/2. And then our x is over here 2 plus b. If we were to simplify this, this will give us the 2 cancels, so you're left with negative 1 plus b equals 1. And then to solve for b, you simply add 1 to both sides. So you get 2 equals b. Now, for what it would be we got to put it in this form, y equals mx plus b form. So what is our slope? Our slope is negative 1/2 x, and then our b is plus 2. So this is part B, and this is when it's perpendicular. So if you graph this one, 2x minus 3, 2x minus 3 half, and then this one, you would know that they will be perpendicular. So they would intersect. Okay, now the last one is pretty much a word problem. And this involves salary. So it says a jeweler's salary was $28,598 and then $32,900 in 2000. The jeweler's salary follows a linear growth pattern. What will the jeweler's salary be in 2005? So this is definitely a linear graph because it keeps growing constantly. So what do we know? We know that let me write what we know. We know the salary is $28,500 in 1998, and then at 2000 it's $32,900, so it went higher, probably because of inflation. So before I go any further, let's just do a little rough draft. Let's graph it. We know that, okay, so we know it's a linear function. It's probably going to go like this, like a straight line, because it grows. So over here, this is going to be the year 98. This is going to be the year 2000. And this is going to be the year 2005. So this is going to be years, the x-axis. And then our y-axis is salary in thousand. So I'm going to go by 25 and then I'm going to raise it to 5. So this is going to be 25. This is going to be 30. And then this is going to be 35. Okay, now let's plot the points. So at 98, it was 2800, 500, so it's going to be right here. I'm going to label that point 98, 28, 500. My second point is at 2000, 32, 900. So here's 2000, 32,900 would be right here. So I'm going to label that point 2000, 32,900. So now we just got to find the slope of this graph. We got to find the slope of this. How do we find the slope of that? You find m, right? So m is pretty much y2 minus y1 over x2 minus x1. Let me write my 2 points. So it should be 98, 28, 500. And this should be 2000. And then this should be 32,900. Label this x1, y1, x2, y2. So my y2 is 32,900 minus y1, which is 28,500, all over x2, which is 2000, minus x1, which is 198. So the numerator is going to be 4,400, because if you subtract that, that'd be 4,400. And then the denominator is going to be 2, because 2000 minus 98 is 2. And that gives us 2,200. So that's our slope. That's a really steep slope, right? Now, the question says, what will be the salary in 2005? So remember, we have it in this form, y equals mx plus b. So what do we know? We know our slope, and then we don't know our b, so to do that we got to pick a point. So I'm going to pick this point, and I always circle my point because I might get confused. So our y1 is 28,500 equals, what is my slope? Our slope is 2,200. Okay, so what else do we know? What is my x? Our x is 1998, so times it by 190.98 plus b. So when you do the calculation of this one, you're going to get a really big number, 4,395,600. And then this is going to be 28,500 plus b. I want to solve for b, so I'm going to subtract this big number, 395600 minus 4395600. So what is that? What is my b going to be? Our b is negative 4,367,100. So now the question says, what is the salary in 2005? So what is my salary in 2005? We don't know, but we do know we have a linear graph, linear equation. Our linear equation is y equals our slope is 2200, right? Times by x plus b, which is negative 4, 3, 6, 7, 100. All you got to do to find the y value, because the y is our salary, you simply plug in 2005 for x. So y equals 2200 times it by 2005 minus 4, 3, 6, 7, 100. When you do all the calculation, you're going to get y equals 43,900. So in 2005, the salary is going to be 43,900. And that does actually make sense, right? Because inflation, prices always increase during inflation. And it definitely goes in our graph. So at 2000, it was 43. So it's going to go, so here's 2005. So it should be around here, right? 43. And it keeps going up, 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 like that. Okay, so that pretty much wraps it up for this section.